We're going to look at trig equations again, this time with cosine, using the calculator. So here's my first example. Cosine of theta is equal to 1/5. And I'm looking for a theta that lives between 0 and 2 pi. So the first thing I do is go ahead and rewrite that as cosine inverse of 1/5. That's how I come up with my angle theta in radians. So if I go ahead and pop that in the calculator, given that my calculator is in radian mode, this is what I end up getting, 1.3694 radians. Now looking at what that represents on the unit circle. Okay, so this 1/5 is the horizontal distance on that x-axis. So this value right here, 1.3694 radians, that corresponds with this point. So that would be the radian measure of the angle that corresponds to this point on the unit circle. So I'm going to go ahead and label that right there. So 1.3694 radians. So now what I need to do is figure out what this other point will be. Angle will be. Okay? So what we want to notice here is that if we travel from our starting point 0, in this direction we get a positive 1.3694 radians. So that's my measurement of that angle. Now if we go in the negative direction, it looks like we get the same angle measure. We have some symmetry going on here, except I'm going in the clockwise direction, so it will be negative 1.3694. So if this corresponds to a negative 1.3694, I need to add 2 pi to get all the way around to a positive angle measure in radians between 0 and 2 pi. So I'm going to take 2 pi minus 1.3694, and I end up with 4.9138 radians. So that's the angle measure corresponding to this little point right there. So these are the two angle measures in radians that yield an output of 1/5 for cosine. Now let's consider cosine of theta being a negative value. I chose negative 2 root 2 over 7. And remember that we're looking for theta in radians because I'm looking on 0 to 2 pi. So as I did before, first thing is to rewrite this statement as theta being cosine inverse of that value that was given. And this is what the calculator pops out for me, 1.9867. So we need to see what that looks like on the unit circle. Because right now, just looking at that value, it's hard to imagine where that lies. So the easiest thing to do is to look at this value for the output of cosine, pop that in the calculator, and I get negative 0.4041. So because it's negative, it goes in this direction from the origin on the horizontal axis. So I've gone a little bit less than halfway. So that means what the calculator has given me corresponds to going straight up this point in the second quadrant. Now that should make sense because when we're talking about cosine inverse, the range that I get ends up being between 0 and pi. So when I'm talking about a positive output for cosine, that lives in the first quadrant when I pop it into the calculator, just like we saw in the last example. Now if I have a negative output for cosine, that has to live over here in the second quadrant. And remember, that's just what the calculator is giving me. Okay, so I went ahead and labeled that point right there. So this is the radian measure of this angle right here. Okay, so now my goal is to figure out what this radian measure here would be. So starting at 0 all the way up here, okay? So I need to figure out what that angle would be in radians. So that would be in the third quadrant. All right, so notice that this little arc right here is equivalent to this arc, okay? Now, I think the easier thing to do is to go over here to 0 and think about the larger angle. So this arc length right here, which corresponds to 1.9867 radians, that is equivalent to going in the opposite direction. Okay, so starting from 0 and going in the clockwise direction, negative 1.9867. So just like I did before, if I consider taking that negative radian measure and adding 2 pi, just so that I can get it between 0 and 2 pi, okay, I end up with 4.2965. So that would be the radian measure of this arc length or angle. So it looks like I have 2 answers for this one in the second and third quadrants. One that the calculator gave me and one that I calculated by taking 2 pi minus that angle in the second quadrant, both in radians.